Tom, is that meeting started recording on yours?
Looks like it, yeah.
Brilliant. Well, thanks everyone. I will pass you over to Tom.
Brilliant. Thanks, Alex. Hi, everybody. For those of you that don't know me, I'm Tom Dorban. I'm a senior advisor in flood and coastal risk management at the Environment Agency. We've done a few NFM Studio sessions before now, so some of you will be very familiar with this. Equally, some of you, this is new to. So we are going to go back over a little bit of old ground, explaining what the tool is, why we're here, how it works, those kinds of things. But the primary focus of today was to do a detailed run through of how to use the tool on a case study in East Devon. I'm joined by Dave and Emily from Atkins. So if you two want to introduce yourselves in turn, I'll just get the slides up whilst you're doing that.
Hi, yeah, my name's Emily with Atkins. Alongside Tom and Dave and some other colleagues at Atkins, we've developed NFM Studio, which we're obviously going to run through today. And yeah, I was been quite involved in all that. So I'm going to help run through, sort of do a bit of a demo, which should be good.
Morning, everyone. I'm David Gasker from Atkins. I'm the product owner for NFM Studio, so working alongside a team. Obviously, Emily is the technical lead for that, helping, supporting Tom, and yeah, looking forward to showing it to you today and seeing how we can use it for some projects.
Brilliant. Thanks both. So in terms of content, I'll quickly run through kind of why we've got to the point where we needed the tool, the sort of intended uses of it and that kind of thing. Dave will describe, what NFM Studio is from an Atkins perspective, what it contains, what it's able to do. And then Emily is going to lead us through, how we've applied it to the Southwest and doing that demo. After that's finished, there'll be a little bit of discussion about ongoing support. Keen for your feedback as part of that as well. As Alex has said, we can kind of pick up questions and stuff as we go through, but I'm guessing we'll have a wrap up at the end as well. So in terms of why we needed it, well, the list on the left-hand side, I'm not going to pretend anybody's going to read, but it's all the actions in the National Flood and Coastal Erosion Risk Management Strategy that say we ought to be doing more work using nature-based solutions. That's really important. That document has started to change how we work from a concept of just protecting people to looking at resilience to flooding and adaptation to climate change whilst we're trying to achieve that. So it's changing the way that we do things away from purely kind of protection and warning, and the solutions that we use to it are also trying to be changed as well. A lot of the agency's carbon footprint and Risk Management Authority carbon footprints actually come from construction works, the majority of which for the agency is our flood defence programme, ironically. So there's lots of stuff in there about trying to become greener, lower carbon, promoting more nature-based solutions, tackling problems at source, all the sorts of things the Catchment Partnership and many of you talk about before. Equally though, to understand how we're delivering against those things, we need to be able to analyse progress against them. So there's some things in there which are very sort of high level, very strategic, but there's others which are much more about actually delivering these activities. So to know that we're delivering them effectively, meeting the goals of the strategy, I didn't feel that we had a tool that helped us do that to start with. I also got asked those three questions on the right-hand side on a pretty regular basis a couple of years ago, and I didn't have a kind of consistent evidence-based answer for them. So, they're fairly simple questions in many respects, but we didn't have something that pulled together the various data sets that we already owned, that were already in existence, to give us that kind of overview. The things that we did have, there's a couple of screenshots here. So the top one is some work that was done for us as part of creating the Working with Natural Processes evidence directory. For those of you that don't know that, I'll put a link in the chat in a minute. It's a really good kind of repository of about 65 projects, nature-based solutions projects, looking at what they could do, how they were developed, their costs, the issues, learning derived from them, all that sort of stuff. The mapping was done to sit alongside those case studies to promote these sort of solutions in other locations. However, it didn't do anything in terms of benefits assessment, and it wasn't that easy to apply those polygons to a flood risk model. At the bottom of the screen, we have our GIS that we have, which is sort of micro catchments. So those red polygons are kind of a 1 to 2 square kilometre size, just to kind of get your eye in. It's roughly the same area upstream above you, Tracy, in the picture above. But it shows the detailed sort of source of pathway receptor model that we can have in catchments. And it's really useful to understand the natural behaviour of water. So if you couple those two things together, you get quite a nice understanding of where the water's coming from, what route it's taking, and where it ends up, and also where you could cite some solutions. However, all those activities on the right-hand side, we're starting to use this information, but it wasn't kind of grounded in, well, how much benefit is there in doing solution X in this location? Which thing is most effective? So it was of its time. That's about 4 or 5 years old now, that top map. But we felt we could do something that was perhaps a little bit more interactive and useful for those user groups on the right-hand side. And there's also something, I'll kind of gloss over this a little bit, but around proportionality. So for a traditional engineered flood defence scheme, which could be, you know, tens of millions of pounds if we did something like Exeter again, the modelling that goes with it, the evidence that goes with it, and the kind of justification for that work is proportionately quite high value as well. So to apply, and that's what we're used to using, is kind of detailed hydrodynamic modelling, hydrological assessments, hydraulics around structures, how water behaves under a bridge or through a culvert, and all that kind of detail. But that level of granularity isn't directly applicable to an NFM scheme. Often NFM schemes are about, you know, hundreds or thousands of smaller solutions spread out across a catchment. And if you look at an individual component of that piece of work, it could be down to a value of, you know, several £100 rather than, you know, thousands or millions on an engineered scheme. So that kind of balance of proportionality between understanding the problem and delivering the solution doesn't translate between the way that we do things for an engineered scheme and an FM. So we also needed a tool that gave us that more proportionate assessment that allowed us to look at the upper catchment and then potentially take the outputs of how the catchment itself was behaving and feed it into one of our detailed flood models, which we have within the communities that are at risk. So we have the detail where it matters and the ability to feed in data above that point. Also, that kind of traditional approach doesn't look at any natural capital benefits. The work in communities tends to be of a much more engineered nature, linear flood walls and things like that. So the natural capital opportunities associated with those things are understandably a lot lower. However, the work in the upper catchment needed to have that understanding of multiple benefits. So if you're looking at it from a biodiversity point of view, or from a carbon or a soil health point of view, you could use this tool, and flooding comes alongside that as an almost secondary consideration. There's no way that would happen with the traditional approach, and that's one of the things that we wanted to try and achieve. So lots of aspirations there for the piece of work we've just sort of coming into the end of. The green bar at the top is the process we've gone through to kind of go through scoping. So with Atkins, we looked at all the existing tools that were available, including a couple that I've just described and several others. We talked about the shortcomings of them, whether they were effective or ineffective. We set up a steering group with local and national input and sought advice from a different bunch of users about what could and couldn't be beneficial for them. Tested it on 3 catchments around Devon and Cornwall, chosen because they were representative of the wider landscapes that we could be working in, the types of solutions, the types of situations where we would be applying it. And the blue boxes below are basically the outcomes that we wanted from it, to be able to look at hydrology, to be able to look at natural capital, and show the impact that can be made through delivering nature-based solutions on both of those aspects. It was important that we recognised most people that use this might have some sort of access to GIS, but not everybody will have a licence or access to a system. So an ability to use an online tool or something as simple as a sort of dashboard, which we'll show you, is there. But there's also the ability to use all the GIS files and stack them up with all the other information you have for your pre-existing activities as well. When it comes to kind of the outputs, then we wanted to have mapping products that would allow us to look at the strategic level, compare place with place, and prioritize a higher geographical scale, but also get into the detail of, well, what's the best field? What's going on at a farm scale and that more granular level of information? We wanted to make use of the best available existing NFM information, accepting the science and the evidence base is increasing quite rapidly, but knowing that there was probably enough there to do something that was usable at this point in time. I recognise that's going to evolve quite quickly, and we know there may be some work to do in a few years' time to catch up with how that's evolved. As I said, we wanted to align it with that ability to plug in outputs into pre-existing flood models or our appraisal processes to look at how we can unlock funding. And a fundamental that came back from the steering group was learning from the issues of other data sets like host, for example, and soils, and making sure that the products were free of intellectual property and they could be used by as many of you without need for complex licensing and things like that on an easy basis. So in terms of using NFM Studio, I'll very quickly go through this one, and then I think I'm handing over to Dave to talk about the tool itself. We've got a catchment, we've got a whole bunch of different people working on it on different things, and we've got the community down at the bottom end, which are at risk of flooding, at risk of increased pollution, all sorts of issues from climate change and urban creep and so on. So the tool should allow us to look at locations, priorities, determine what options in certain locations could work, help identify where field work would then be best placed to go and refine those ideas. You can then take that refinement, apply it in the tool, get outputs for hydrographs for the flood, for high and low flows, and for natural capital. And then if you need to, not everybody would, plug that into a flood model that exists for that community or catchment. Or if you don't need to do that step, just go straight into applying it to whatever you do, however you work in your kind of pre-existing arrangements for your organization. So I think that's the overview bit of why we needed to get here. I'll hand you over to Dave now, who'll talk through the tool, and I'll do the moving of the slides. Dave, if you just tell me when you want to move on.
Thanks, Tom. Okay, good morning, everyone. Just pass through. What I'm gonna do is I'll just provide a brief description, actually, of the physical basis of the tool. That is to say, how it works, how some of those things that Tom's just described are actually calculated in the tool. Some of you, I think some of you have certainly seen this before, so again, apologies. For those of you that haven't, I'm assuming that we'll be sharing the slides, won't we, Tom? Like I say, do reach out if there's any particular areas that you're particularly interested in.
Yeah, we will share the slides.
Yeah, okay. All right, so I mean, Tom's given a very sort of coherent description of why we needed the tool. But I think that the most important part, almost at the start of all of this, is to say that it is a computer model, I guess, but it does sit very firmly in it's a simplified computer model, so it's not dealing with all the detail of the hydraulics and so on, and it's also just meant to be something that gives you a bit more detail than some of the previous NFM mapping. So it does have some sort of modeling aspects within it, which I will just run through for you now. Next slide, please, Tom. It's something that has been sort of developed in partnership with mainly the Environment Agency, but also a number of other organisations over the last sort of few years, really. So it is tried and tested across some of the catchments that you can see, and that includes projects where we have used it before, and also projects where it's being used at the moment. You can see some of those here, like the River Calder, the Evenlow, the Froome, Yeo, Wriggle. These are all some rivers that some of you may know of. So there's a lot of activity in this space. So it's not a static tool either. It's continuously evolving as we go through. Next slide, please, Tom. Tom sort of intimated this already, but I guess there's three very particular outputs. As you'll see when we get to it, there's a lot of information that you can extract from it. But if I synthesize that down, I think it does three main things. So it identifies where the best opportunities are for for NFM. So what are the most suitable fields where NFM interventions can be applied? And it's important to note that the entire tool is intended to provide information at the field scale. So you'll see lots of regional maps or catchment maps, but the information that's contained within it can be interrogated at that field scale. And I'm sure that's something that we can pick up on the demo later. The second thing, as Tom said, is that it is very much intended to provide an estimate of the hydrological benefits. And that's to say, what is the potential volume or the volumetric benefit that can be provided by NFM? A lot of the previous information obviously is done on a sort of no regrets basis. And what we're trying to do here within NFM Studio is actually put some numbers to that can be used to help everybody with making business cases for some of this, and also to be able to communicate to the local communities that are at risk, that we're trying to protect, what sort of benefit some of our work can provide. And then the third element, of course, is that, you know, in doing NFM, we all know that it's not just about the water. When we do some of these activities, we can deliver all sorts of other multiple benefits, things like, you know, carbon, biodiversity, and so on. Increasingly, where we're making business cases or trying to communicate the benefits of NFM, an understanding of the type of multiple benefits that we get, and also to understand the scale of benefits that we get, can really help us to promote some of these schemes and bring people with us in some areas. Next slide, please, Tom. So this is just really a flowchart that tries to break that down and show the sort of the flow of information, I guess, that the tool is actually using. And on the left-hand side here, you can see our opportunity assessment, our hydrology, and the natural capital, the three things that I've just described. Each of those has a suite of different maps that come out from that particular assessment. And again, that will be something that we can sort of talk over when we get to the demo later. But in terms of, you know, how that information is then used, which is a really important point here, we're trying to use it to spatially prioritize NFM interventions. So where are the best strategic locations? In many cases, we'll know where those are, but in other cases, we might not, simply because the catchment might be very large, or it might be that we've traditionally focused on a particular area. So what we're looking is a holistic view across a whole catchment area to identify where the best places might be for NFM. And the second bit in the middle there, the indicative effect on the hydrograph. So as a hydrologist myself, I spend a lot of time looking at hydrographs. We need to understand, for anything that we do, what the effects are on that hydrograph, and in particular what the effects are on the flood peak and on the duration of any flood, which are the two sort of factors that I guess affect the communities that are at risk from flooding that we're trying to protect with some of these measures. And so the tool is actually a decision support data set for NFM implementation in a catchment. As Tom mentioned at the beginning, you know, many of you will have particular sets of information for catchments that you work on or that you've been working on for a long period of time, and it's intended to work alongside that. It's not intended to sort of replace all the information that exists. It's another element of the decision making process. And so far, I think it's been used in a variety of different ways. It doesn't really have one size fits all, we've noticed, and I'm sure that, you know, with a number of us on the call today, there'll be other ideas as to exactly how this information gets used. But the first one is obviously around visual engagement. It helps us to communicate, like I've been saying. It also helps identify pilot schemes. So sometimes, you know, we can't necessarily start an NFM scheme at the complete catchment scale. We might want to sort of identify where the best place to start is, a really important part of any NFM scheme. And it's also been used in a sort of broader strategy sense as well. As Tom mentioned, from the Environment Agency's case, you know, it's really important to be able to make a business case to unlock the funding to help everybody deliver some of these schemes. And going forward, the natural capital assessment element has been a really important part of developing strategies on net zero and what space NFM can fill there. Next slide, please, Tom. I won't dwell on these too much, but one of the key things we're trying to do here is just to accelerate the rate at which NFM gets implemented by promoting discussion. Sessions like today. How do we think about NFM and how can we develop schemes? What information can we provide? The whole thing around open sourcing is really, really important to us, as has been mentioned previously. And with regards to the acceleration, this whole thing about just making a start, it's actually one of the hardest parts of developing an NFM scheme is actually making a start, as I'm sure we're all aware. It needs to be based on industry standard approaches, which the whole tool is. It's available to use. It considers those multiple benefits. And again, it is intended to be adaptable as part of a broader suite of information that you will have and that will sit alongside the types of information that you're already collecting if you're involved in these types of schemes somewhere. Thanks, Tom. Next slide, please. So one of the sort of key things, if you look in any document around NFM, is that there's a very long list of potential ways in which natural flood management can be implemented. And that's simply because, every catchment is slightly different. And there's different ways in which I might be able to either reduce the amount of runoff from land, store it, or attenuate it once it arrives in a river or a watercourse. And so in NFM Studio at an early stage, we made a decision to actually simplify some of the interventions and the way in which we look at it. And so we've broken it down, and you will see information on 3 main things. The first one is the way in which changes to land use, for example, can reduce the amount of runoff from a piece of land by its effects on reducing the rate of infiltration to soil. And that's what we call the land opportunity and runoff reduction elements. The second element is what we call catchment storage. That's to say places where can we store water in the landscape where it's not being stored currently to actually reduce the rate of water movement through the catchment down towards any communities at risk that we're trying to protect. And the third one is what we call in-channel attenuation. So what can we do within channels and watercourses once the water has reached there to slow the flow? So that's the sort of key one. So there's those 3 elements that the tool provides separate information on. Next slide, please, Tom. The way it does that is not dissimilar to some of the other pieces of kit out there that have been produced before, but it's basically looking at a whole suite of GIS data that describe the physical character of the catchment to decide where the best places are to do that and what the main constraints are as well, and that is what gives us then the opportunities that appear to exist within the landscape. All of these data, like we say, are available, I think, through Tom, should you need them. I'm sure we'll discuss that later. But they are all industry standard data in any case. But there will be some things in there that you may not know were available. So that's something to bear in mind going forward. Next slide, please, Tom. It has incorporated local knowledge. So through the process that we've gone through, a whole series of workshops and so on have been held to actually make sure that the data that we input in the model are moderated in a way that reflects local issues. Obviously, like I say, every catchment is different. So, in any given catchment, some of the issues might be different to another. So you do, whereas it's a computer model and it's a tool and the data give you a certain amount of information, it is always important to make sure that information is moderated according to local knowledge. And I'm sure something that we can talk on later. Next slide, please, Tom. And just a quick slide just to show how some of this information can be moderated, or in this case, this is an output from one of the workshops that we've done. But I won't dwell on that massively at the moment, if that's okay, but we can come back to that later again. Next slide, please, Tom. And this is basically what some of the outputs start to look like. So for the opportunity mapping, you can see a color scale is used, a traditional opportunity map really. The higher the number, the opportunity score is from 0 to 1. Okay, so it's like a normalized scale. The areas in red are predicted to be more favorable for NFM, in this case, runoff opportunities within this particular catchment. And this is one of the pilot catchments that was referred to previously, sorry, the River Otter, which is also in East Devon. Next slide, please. So that just tells us, I guess, where things are best. And one of the key challenges was also to say, okay, well, what benefit do we actually get if we apply those types of measures in this particular location? And as described, the tool has this volumetric assessment. Again, it's all based on industry standard data that is routinely used and is available for the EA and its partners. And the calculation itself is for the 3 measures that I just discussed earlier. There are separate calculations that are being done for each of those measures, and they're combined into an overall hydrology calculation. The spreadsheet itself that is used for the calculation, there is a spreadsheet, a hydrograph calculator, hydrology calculator for each catchment that is available to you as well. So it's not just the maps, it's also, if you want to delve into the effectiveness of what you're trying to do, that is also available for you to help. Next slide, Tom. Okay, and then just a really quick run through now, there's the sort of modeling element. So how are these things calculated? So the rainfall runoff calculation, this is what is being used to actually work out what the changes, sorry, in the runoff from a field if we change land use, for example. And a particular computer model here that's used is called the daily based Morgan-Finney model. Again, it's a published model, it's a tried and tested model, but it is a simplified representation of the hydrology of any given field. And so all of those GIS data are used to actually run an assessment like this in the tool to give you an estimate of the runoff reduction that might be expected from any particular intervention that you choose to make. Next slide, please, Tom. The second type of measure is the catchment storage. And in this sense, the tool conceptualizes this as basically a series of bunds that are located along particular flow pathways. So during a flood, if we go out into any catchment, pretty much, we'll be able to see the pathways along which the floodwaters are moving. And a very traditional way of doing NFM is, of course, intercepting that water by creating a bund and storing it before it reaches the watercourses. There's 2 particular ways in which the tool simulates or estimates the amount of storage that's possible along a flow pathway. On the left-hand side here, we can assume that there's a single bund, okay, along any flow pathway that we see. And there's GIS data actually in the tool that describe exactly where these flow pathways are expected to exist in the landscape. And the model assumes that each bund is 0.5 meters high. That is an assumption. So, we could have smaller bunds, we could have bigger bunds in particular locations. But for the purposes of the calculation, we assume that that is the maximum height of a bund. The choice of elevation is simply once you get to bunds that are of a greater dimension than that is where you start to move into sort of greater engineering requirements in terms of the stability of banks and so on and so on. We wanted to avoid incorporating those more complex hydraulic structures into the model. On the right-hand side is a second assessment that the tool does, which is to say, okay, well, if we maxed out and did as many bunds as we possibly could in one field, how much water could we store? And that, as you can see on the bottom right-hand side, where we have steeper slopes, for example, to capture the amount of water that we want, we might need more bunds. So that's also one of the reasons to include that second function in the calculation. Next slide, please, Tom. And then the third element and how it calculates it is what's happening in the channel. And in this sense, and on the sort of edges of the floodplain. On the right-hand side here, you can see a series of woody features that have been introduced within the channel itself. And for the purposes of the calculation, the purpose of a wood feature really is to both slow the flow, but also to create storage behind it that can be occupied during a flood, which is the type of thing that we're trying to simulate the effect of. And we actually use what's called the FARL index, which is it's a number basically that describes how much storage is actually available within any given river channel or floodplain. And so as we introduce more wood features, the FARL index actually drops, and that actually then helps us to simulate what the effects on slowing the flow. How does the hydrograph get, how much additional storage is provided, and also how much does the hydrograph get slowed down. Next slide, please, Tom. In terms of the hydrographs, again, the key thing really is that we're using an industry standard approach. It's the FEH, the Flood Estimation Handbook. It's actually been around since the 70s. In fact, this is has evolved in over many decades now, and we now have the ability basically for any catchment in England certainly to actually calculate or estimate what the flood hydrograph will be. What is the peak flow? What is the peak duration of any particular flood event? And that is very much the basis of this particular tool, the hydrology calculator that I've mentioned before. Next slide, please, Tom. Okay, so the previous map that I showed of the River Otter was basically all about the opportunities. Where is likely to be the best place to actually do it from a landscape perspective? But it's important to note that may not always necessarily be the same as where's the most effective place to do something. And that might be simply because a larger field, for example, can actually probably provide a much greater reduction in runoff just purely on the basis of size. There may be particular issues around the particular land use somewhere. So it is really important to look at not just what the landscape suggests is the best place to put it, but where the greatest benefit is expected to be achieved from a volumetric perspective. I think so using the outputs, and I'm sure this will come up when we do the demo, it's basically trying to play the balance really between where the best places in the landscape are and where the greatest benefits are likely to be. And that's a really important point for sort of NFM and the distinction, I guess, from no regrets type schemes to just thinking maybe about, okay, well, what is the best, most effective place to actually put NFM? And so there's maps within and data within the tool that will help you for anywhere in southwest England, including East Devon, as to where the best places are. Next slide, please, Tom. And like I say, the way the balance plays out and something that can be done as well is to basically help based on the opportunities and the volumetric scores is to identify where the best places are to focus first. So we talked about like pilot studies and so on. Combining the information gives you that extra bit of detail to get started on any NFM scheme in any particular catchment. Next slide, please. This is just basically a diagram that just shows how within the hydrology calculator the hydrograph is adjusted depending on different the processes that are being modeled by NFM Studio. On the left-hand side is basically anything that's to do with land use change actually reduces the peak of the flood. Here, anything to do with flow pathways, most storage elements in an NFM scheme will fill during the rising limb of the hydrograph, so the beginning of the flood. And once water arrives in the channel, it's slowing the flow of water. So what the hydrology calculator is doing is for any intervention in any catchment is running through that three-step process to give us an estimate of what the baseline hydrograph was and what it would be after NFM. And that's the basis of the assessment of the effectiveness of this scheme. I will add that this is for actually a low order, an annual flood event. Some of the reductions are variable depending on how severe the particular flood is or we expect it to be. Next slide, please, Tom. The other thing that we've done as part of this is obviously there's lots of different ways that we might think about NFM in any particular catchment, but what we've tried to do is just try to break it down in terms of firstly the severity of floods that we might want to consider. So the tool looks at the mean annual flood, so what's the 2-year here, what we might call a nuisance flood. How effective is it at these sort of nuisance floods, all the way through to the types of floods that we might traditionally consider as part of a flood risk management strategy, which is the 1 in 100 year flood. We also look at different combinations of measures. So for example, what happens if we just do some of these land runoff or land use change measures? What happens if we do that, but we also put flood storage in place along flow pathways? And then, what happens? What does the hydrograph look like when we implement all of those measures? So again, all of those things, depending on what your particular design or desire is for a particular catchment, can be run through the hydrology calculator if you need. Next slide, please, Tom. And then finally, this really important point around, it's not just about the primary objective of any NFM scheme is, of course, got to be around flood risk management, but we do have to acknowledge and communicate all the additional value that comes from some of these schemes. And it's really just to emphasize, some of the projects where we start to look at this in great detail actually show that, in some cases, the additional benefits that we get actually far outweigh some of the sort of flood risk management benefits that are delivered by NFM schemes. And that's a really important thing to think about when we're making business cases for some of this. Obviously, primarily, we have to communicate the benefits that we get for flood risk management, and that's the reason why NFM Studio is very much a sort of hydrology-based tool, but it also gives you the opportunity to think about what these other benefits are and communicate that. Next slide, please, Tom. The data that are used to calculate the multiple benefits on natural capital is very similar to the other open source data that are used. So it's looking across the landscape. But a really key important point of NFM Studio in particular is that it is trying to quantify and monetize that based on industry standard calculations. The Environment Agency, for example, have a particular tool that is being used for that. And the idea is to sort of scale that across the whole landscape to give not just the hydrological benefit, but also what the natural capital benefits might be. Next slide, please, Tom. And this is just really just another flowchart that explains some of the data flow, I guess, associated with that, which I won't delve into now. But again, if you've got particular interest in this, do please reach out to any of us, and we'll gladly go through it in a bit more detail. Next slide, please. And we'll skip over this slide as well, please, Tom. Thanks. Okay, well, hopefully that just gives you a sort of a flavor of the different types of the physical basis, like I've called it, of the actual model. I appreciate that there's quite a lot of information in there. If you are particularly interested in any a particular technical element of it, like I say, do please reach out. We're always happy to talk about technical things like that. But what we'll do now is I'll just pass you on to sort of the practical side of things, that and how you can use the tool, what it actually looks like. Actually, that's just what's sitting behind the bonnet almost, which hopefully will at least help you to provide some context. So over to you, Emily.
Hi there. Yeah, before we delve into the sort of demo of things, is it worth just asking if anyone has any questions about what Dave or Tom have discussed? I'm sure it's just a lot of information all at once.
We have just had one question from Tim Youngs. Tim, I don't know if you want to just, I know you've just written it in the chat, but just take yourself off mute and you can ask that to Dave and Emily.
Yeah, it was a little bit, hi everyone, just a little bit generic, I'm afraid, but it was about, I'm just thinking in terms of running the three combinations of the three scenarios. How do we know when we've done enough? Because we could carry on doing loads and loads of nature-based solutions, which is all brilliant and great in terms of climate change scenarios. But do we pin it back to properties at risk? And because when we're putting business cases together for funders or whatever, it helps to know where the threshold is, where the point we're trying to get to, and then we can work backwards, and if that's making sense. So I was just wondering, taking the River Otter as an example, what that looks like, because on the Colne catchment next door, we've pinned it back to one of the things we pinned it back to is Heel Railway crossing on the mainline railway. So I was just interested in other places. Thanks.
It's a really good question, Tim. So I think it might be a little bit of a convoluted answer, but bear with me. It depends on what your interest is. For me, it's going to be about trying to achieve flood resilience in those communities. To a catchment sensitive farming officer using a tool, they might only care about pollutants leaving a farm and reduction in discharge of X, the amount of dilution or something at farm level. Or an NGO advisor might be looking at soil health and what could be done, how much improvement could be made on a specific farm. So I think the problem is, because of the multiple benefits that can be derived from NFM, there's several different answers to that question. But around, my world and unlocking funding and business cases, it's about the scale of the impact you can make in the community that's at risk. So how many properties can you move down a risk band or two? Now, the reason I said this might be a slightly convoluted answer is because in the background, behind all of this, the way that the agency appraises flood risk projects is being reviewed. Some guidance has just been released, but NFM wasn't specifically part of that. Now, there's a couple of test cases that are being worked on where there are some assumptions that will be made about how much change could be derived from an NFM scheme to unlock the funding. So I think there's sort of two aspects. There's how do we meet the appraisal guidance rules to unlock the cash, and what's actually meaningful within the community. And I would say that the target would be to understand what's a meaningful change in the risk to that community. How many properties can you decrease the risk to? So many of our communities have inundation models in them. We were able to plug in the outputs of NFM Studio, those hydrographs that Dave shared, into that model as a sort of new baseline, if you like, and then see how different the risk is. So I think there's a sort of iterative process there of coming up with what could be done in the catchment and seeing how much impact it has in the community. For my world of work, that will always be the baseline, is how much difference can be made. The unlocking the cash is a sort of process and a mechanism that we have to go through, and there's rules that will enable that. But it's about this, for me, the scale of difference in resilience. Have we moved properties from a flooding in a 10-year return period event to a 50-year or a 20-year, or have we managed to increase the level of resilience that way? Inevitably, there'll be other ways of looking at it around low flows, sediment, depending on your area of expertise and your interest. And the tool can help you with those, but the sort of ethos of it is very much around, resilience to communities.
Thanks.
Can I just add just one thing to that? I think it's a really, really good point. I think the way we've addressed it within the tool is that we actually look at the maximum potential within the tool. So that's where we're working back from. Is, I guess, if we did as much as we can everywhere, what sort of effects might we get? And then that should help you then sort of scale back from there. I think the key really to say as well is obviously, we like to think about things at the catchment scale, of course, and that's great. But I think the value of particularly the data that comes out of this is that it allows you to look at particular areas of a catchment where you might need more resilience. So whereas in some instances the catchment scale we might see a smallish benefit at a particular community, we might see a much more significant benefit from NFM. But I think the starting point, in answer to your question, is probably just start at the maximum. Is it enough? And move back from there. Maybe that would be my take on it, Tom.
Is it enough, and is it realistic given the landowners and the local intel? Exactly. It's always that balance of how much do we need to do to achieve the desired outcome, ground truthing it in reality of the catchments and the landowners that you would all know of. Actually, only 50% of that is deliverable, and that kind of helps you massage those two variables to get to your intended scale of NFM, if you like.
We've got another question come in from Tim from the National Trust. He's wondering, can we use the studio to work on sub-catchments or park catchments? And I think he's most interested in focusing on looking at Killerton Estate.
We can probably pick this up a little bit in the demo, but yes is the short answer, but it does require a couple of little injects of other information from outside of what we've created. Depending on the level of detail you want to go to, if you only want to go part way through the process, you can probably get everything you need from the tool. It has been a little bit limited by a couple of things. One was obviously money. So with the budget we've had, with the work we've done as a team, we've covered the whole of Devon, Cornwall, the Isles of Scilly. The kind of restriction has been, well, how many catchments do we slice that up into? And we've got 262 catchments and 8 million fields in the tool. So there's a whole host of information, but the way we sliced it up has partly been limited by amount of funding, amount of data that we'd have generated, but also the sort of capabilities of the online dashboard. So the dashboard perhaps is more limited in the way that it could help you answer those things than the GIS behind it would be. But it will, depending on your level of interest. I don't know, Emily, if you wanted to say anything about this, we'll cope.
No, definitely, and it's something I'll definitely pick up in the demo. So I'm going to hijack the presentation now and share my screen, and we can move on to that, and I'll definitely sort of talk about how we can look at sub-catchments and things. So this is the NFM Studio Devon and Cornwall dashboard. A link to it is in the presentation as well, so that make sure you all have it. When you first come to the page, this is what it looks like. It's structured across the top in various different tabs. The first tab is the sort of introductory tab, which has project information, and there's also a link to the technical report as well at the bottom, which has a little bit more information as well about the methodology that Dave will have gone through. I'm going to quickly talk through sort of ins and outs of it, and then delve into sort of East Devon and what we can do. So the next tab is a user guides tab. This sort of explains the dashboards a little bit and also has some links to YouTube tutorial videos that we put together. The next one as well is the Catchments Overview tab. So this is sort of the dashboard that you would see. On the left-hand side, we've got these sliders, which allow you to sort of filter what data is visible on the map. Map is obviously in the middle, and on the right-hand side, there's sort of some big indicator values, which sort of give you a summary of what is visible or selected on the map. We have the layers button, which is here. So if you click that, a drop down of all the different layers which is available become visible. So at the moment, the eye is sort of open on the opportunity metric, so that's what is visible. So this is the opportunities part of the assessment. And again, on this catchments overview tab, everything is summarised on for those catchment levels. And again, it's the 262 catchments, so it's just a catchment summary here. If I turn that off, and we can put the hydrology metric on, so this is one of the outputs from the volumetric assessment. So it's available, and also in here we've got some of the OM for initial screening and further assessment outputs as well, which you can turn on and view alongside the other NFM Studio outputs. So if I stick with this bit for a minute, I can just show how the sliders work a little bit. So the sliders are linked to each of the data sets. So obviously we've just turned on the volumetric output, so we'll be looking at some of the volumetric slider to be able to use with this data set. And again, it'll be the volumetric type indicator step change if you were to change the slider here. So if I start moving it towards the higher end of the scale, it filters out those lower catchments and updates the indicator accordingly. The grey icons tend to link to the opportunity ones, just to try and keep that visual separation between the indicators. So yeah, this is sort of a helpful view across the different catchments within Devon and Cornwall. Then when we look at the field scale data, that is separated into the management catchments, and we separated Devon and Cornwall into 7 management catchments, which each have their own tab. So I'll look to East Devon, and in these management catchment tabs, there are 2 dashboards. One dashboard showing the opportunity and hydrology outputs together on one dashboard, which looks like this when it loads. Very similar layout with sliders on one side and the indicator values on the other. And then below that, there is also the natural capital dashboard, which looks very similar. We'll have, when it loads, the sliders on one side and indicator values on the other side, and we've got it with a nice little bar chart as well. I'll go through that in a minute. I'll first go through the opportunity and hydrology dashboard. It loads. So again, when it first loads, it's the management catchment, so the catchment summary level, and we zoom in. I think we're interested in the beer catchment. We can zoom in and it will flip to field scale outputs. Another little useful way to work around the tool is that if you know the number of the catchment, which is over the top, then you can jump straight to it. So for example, 193, it would, I say, jump straight to it when my Wi-Fi works. So you have to click there, and then it zooms in. Or if you wanted to use, if you know the name of a village or a location or a town, you can also find a place by using this search button here, and it will jump straight into the beer. So yes, and then now we can see it at the field scale output, and this sort of helps you prioritize field between fields. You can see there's this particular area here, the middle of the catchment, that is coming out a higher volumetric reduction. And similar to the other tab, the different layers are available are in here. At the moment we've got the opportunity turned off and the volumetric one turned on. And for the field-based outputs, there is a shapefile per the 3 NFM interventions that we've calculated volumetric reductions for. So this one is the infiltration, so the land use change, NFM type, and in here shows the return periods for 1 in 2 and the 1 in 100. There are also the 1 in 10, 1 in 20 and 1 in 50 available, but they're in separate shapefiles because we were getting to the maximum size limit that Arc Online was liking. But yeah, if you're interested in any other return periods, they are also available. And it's also worth noting that it's only the land use change, the infiltration hydrology metric that does alter over the return periods because the volumes stored in the buns and in the channel assumed to be static across return periods. So I'll turn that infiltration one off and turn the output for the hydrology catchment storage. So if we were to implement buns, and again, similar color scale. So the darker the color is, the more volume that you can store in that field. The lighter the color, the less. The catchment storage shapefile only shows fields that have flow pathways in, so that's why we don't have a big map of all the fields. It was just selecting the fields that actually have flow pathways in. And again, you can see some dark areas with fields that can store greater volume. I'll turn that off and put the in channel on, and it'll show fields that are neighbouring watercourses. So yeah, I'll put the opportunity on as well, so you can have a look. That's there, and it's worth noting that all the shapefiles and GIS data that it's on the dashboard. Tom does have a copy of as well. So if you need to interrogate it in any more detail, don't like the colours that I've chosen for the map, then you can get a copy of the GIS and interrogate it in a lot more detail. We've had to select obviously colours and also which attributes we've scaled on. Or you can take the shapefiles and clip them to your subcatchments and things like that as well. You could do with some of these shapefiles outside of the ARC Online. So I'm now going to go through how you'd perhaps select some fields within this catchment and implement them into the sort of hydrology spreadsheet, and I'll go through that as well. So, I mean, I don't exactly know what your scheme is in the beer, but what I'm assuming you're looking to protect the communities downstream. So one way you can use the NFM Studio tool is just to look at those fields upstream, for example. So I've just turned the lasso tool on, which turns my cursor into this sort of like dot, and it allows me to sort of select. I'm just going to give a very rough selection, and you might want to be more detailed with which fields you do and don't select if you were to give it a go. And then I can choose the different hydrology metric outputs. So let's start with the land use change, the infiltration, and it selects those fields and that are highlighted in pink, and it updates the indicators on the right hand side to just show the volumes stored in these fields. So because we're looking first at the land use change, the infiltration output, it's just updated this box here. So it's saying that if we did land use change across all these fields, we could be looking at around 3.8 thousand meters cubed reduction in runoff. So that gives you quite nice indicative volume. And make a mental note of that value. It'll be useful when we look at the hydrology spreadsheet. And I can deselect that by pressing the X. And we can do a similar exercise with the other volumetric reduction outputs. So we can turn off the land use change and put on the catchment storage, which is the buns. And we can turn the lasso tool on again and do another big lasso of all these fields. Again, check the catchment storage one, and this will have updated these indicators here. So it's saying of all these fields selected, from the 1 buns per field option, we could be looking at 700 meters cubed, or if you want to put all the buns that you could possibly fit in that field, which is like a big series of buns up the flow pathway, then we could be looking at 11,500 meters cubed as well. And obviously there's difference between those due to the different numbers of buns applied. So again, a useful value to know, gives you an indicative volume that could be stored by those features. We'll turn the in-channel one on as well. Turn the lasso, go away, and just select these fields here, and the in channel, and it's saying that we could store about 62 meters cubed in channel in this area here. And those are useful to know because we could take those volumes and implement them into the hydrograph and see what that might look like. So I'm going to now go to the hydrology spreadsheet, and as Dave mentioned, there is a hydrology spreadsheet for each of the catchments that we've considered, so the 262, and they're numbered based on that catchment number, which is just the ID that we've given it. So you would go to so remember 193. I would go to this link here where all the hydrology spreadsheets are saved, and we'd search for catchment 193 and click download. But to save technical difficulties, I did download it earlier, and it's here. One thing just to note is to make sure you've enabled macros, because the spreadsheet does use macros, and when you download it, it won't necessarily automatically have them turned on. This is the user guide tab. Gives a bit of an explanation around what this sort of workbook does, and sort of breakdown of the tabs. And there's also a link to another YouTube tutorial, which is basically me talking through the exact same thing. There's a glossary tab, which sort of explains some of our terminology, but the main one of interest is this catchment analysis tab. And on here, you'll have the 5 different return periods that we've looked at. So 1 in 2 down to 1 in 100. In purple is the baseline hydrograph. And then in this orange dash line is the impacted hydrograph of if you were to implement all the different types of NFM everywhere in that catchment. So it's a no constraint, all NFM, catchment-wide NFM implementation everywhere. And it takes those volumes across the whole catchment and applies them in a sort of stepwise manner, as Dave sort of mentioned in his sort of part of the talk. And we are left with this post-NFM hydrograph, which is this orange dashed line. And we can see how that might be effective through the different return periods. And we can change the different options that we're applying using these. So the only thing orange relates to this all NFM intervention options. So we can change which measure we want to apply. So at the moment it's got land use change on, but we could change it to woodland creation, and we could change from the max storage bund to the min one if we wanted to as well. So we can see how that might change. And then there's this calibration button, which runs off a macro to help run the musking and flow routing, which is what that's there for. If I go back to it does take a bit of time to run, so I'll try and avoid using that for the demo. So that shows us our all NFM intervention option. That might be useful to show, like what Dave was mentioning, the absolute maximum. What could we see, what kind of benefit could we see if we did everything? But that's not perhaps very realistic. And we might first of all want to know what that impact would be if we were just looking at that sub-catchment that we're interested in, or a certain few fields that we're interested in that from the ARC Online. And we can enter those volumes that we've lassoed into the green boxes here to generate a third hydrograph on here, which would show the selected hydrograph. So I must admit, I saw Dave put that value in the chat. I'll try and make it as accurate as possible. So that was 8,000. Yep. And then we can apply that same volume across the different return periods. And then what it was, but I'm just going to put 1,000 in for the in channel the catchment storage, and it wasn't a huge amount for the in channel, was it? So it was about 80 for the in channel. And we can now see this third hydrograph appearing on our axes here of the selected NFM. So that would be just those subcatchments that we picked out with using lasso, and seeing how that might impact a hydrograph. So that's a quick explanation of how we can use the hydrology spreadsheet calculator. So I'll go back to the ARC Online now.
Emily, could you just show everyone how to get the 100-year infiltration value and the ones in between? Because I think an important thing to denote is that the first map, the sort of strategic all catchments map, had 5 different flood return periods you could change on the left. For the ones that are more detailed management catchment level maps, we only have 2 interactive return periods, the 2-year and 100-year, because of the limitations of the amount of data we're putting into the tool. So those 5 boxes that are in the calculator spreadsheet from 2-year up to 100-year, you can get both ends of it from the interactive map, but the 3 in the middle can come from non-interactive layers, which you can turn on and off in the tool. So they're all there. You just have to make sure you're using the right layer for the right box.
Yeah, no, that's a really good point. Thanks, Tom. So yeah, it's based on these 2 boxes here. At the moment, 1 and 2 is selected, but if we were to turn that one on, it would flip to the volumes that could be stored in the 1 in 100-year event. And again, you could do a similar exercise with the lasso, select your area, pick the infiltration, and then again, you can see these values change here and make a note of them and then implement them into the spreadsheet. And then if you were interested in, so I'm going to turn that layer off, which just shows the 1 in 2 and the 1 in 100. If you're interested in the other return periods, let's just pick 1 in 20, for example. You turn this one on and go through a similar exercise with the lasso tool, select your fields, pick infiltration. And it should have selected, I think it did change, didn't it? It should have selected those there. So that's how you do that. I think that's everything to show with the opportunity in hydrology dashboard. Another thing would be to do is if you're, I think I'll just turn that one off and put the 1 in 2 and 1 in 100 back on. If you were particularly interested in certain measures, for example, just perhaps woodland creation, that's all you're interested in, perhaps you've got a grant just for planting trees and you just want to do tree planting, then you could use the slider for that particular option and find the best locations to plant trees just based on that particular option, if that's what you're interested in as well, or vice versa. If you wanted just to do the catchment, some buns, you could put the bund layer on and use the slider, the volumetric one that's linked to the volumetrics, and look at which fields which could store the most volume from just the buns option. So that's another little useful feature. So now I'm just going to talk through some of the natural capital dashboards as well. It loads. It's very similarly laid out with the sliders, like I mentioned, and instead of having the option to tick between return periods, we've got the option to tick between sort of scenarios. So at the moment, we've got the catchment storage. So if you were to implement buns measure, but if you were particularly interested in woodland creation, we could turn that layer on. Again, at this level, it's just fields catchment summaries, but as we zoom in, it turns into field scale. This is also the layer that's got perhaps the most information in it, so it does take the longest to load. So bear with my Wi-Fi as it tries to load. I'm going to zoom right in so it has less fields to load. But again, you can do a similar exercise using the filters. If you're particularly interested in carbon benefit, for example, you could just look at this, the carbon slider, and filter it to fields that would provide the greatest carbon benefit. There's a bit of a breakdown of how that total benefit looks across the management catchment, and gives some indicative values as well. But again, these values are across the whole of East Devon, but if you're interested in just a certain few fields. You could use the lasso tool again just to select those few fields and see the breakdown of the multiple benefits and the sort of monetized benefit that they could provide as well. And these will vary across the different scenarios that you can apply. And again, the layers are available here, but there's not so many layers to turn on and off. It's just whether it's on or off with this natural capital output. And as with all the dashboards as well, if you were just to click on a field, it would show you. I've got some selected. It would show you the breakdown of that attribute table would appear, and it would show you what information is available within the dashboard as well. So you can see these similar type of values that are presented graphically here, but numerically here as well. So that's the natural capital output as well. I don't know if anyone has any questions, if there is certain things that they'd like to do that they'd like me to explain in a bit more detail. I'm happy to go through that as well.
Just one thing, picking up Ben's comment in the chat from me, Emily, if you can go back to the opportunity metric for a second.
Yeah, of course.
So just so people know, the tabulated data on the right-hand side, when that's loaded up, is for the entire East Devon management catchment. If you zoom in to look at beer, that data doesn't change. It's still showing you 10.4 million cubic meters of storage across the whole of East Devon. So to get plot-specific information, that's where the selection tools, the lasso tool or the circle or whatever, come in. If you want to know what those summary statistics are on the right-hand side for where you're looking at in the screen, don't assume they will update, because unfortunately that's another limitation of the product, or the system we built the product in. You have to get the detailed information to put into the hydrology calculator, or just to look at some overview statistics with a selection tool of some sort. Yeah.
Another way as well, if you were again interested in the beer catchment and want to know those volumetric reductions for the whole catchment, that is also available in the catchments overview tab. You could go to the beer, and if you lasso it here, because it's a catchments overview, so it has all the information for the whole catchment. It will should update for just for the, here we go, just for the beer. So these are the summary, volumetric reductions for the whole beer. So that is also available in the catchments overview tab, where we look at things summarised at a catchment scale. Are there any other questions or actions that you'd like to do? But
Tim's just asked about snapping to a sub-catchment boundary. So looking at Luppet in East Devon, could he select the sub-catchment that's upstream, as a lasso or circle isn't really working?
I guess if the lasso or circle isn't working for you in the tool, then I would perhaps suggest getting hold of the data, the spatial data from Tom, and then anything that you can do in sort of integrating the data in an Arc Online is perhaps a bit, I don't know, I would say a bit easier because it's not all stored online on a GIS like software on your own laptop, and then you can sort of clip the data to whatever boundary then you're interested in, and play around with it like that potentially, if that helps.
I don't know if that's a browser thing, but one thing that's worth noting is that the EA has just been upgrading its laptops. It now works much more effectively for me and much quicker on a Windows 10 machine and using Edge as the browser than it did previously on Windows 7 and with Chrome. So maybe check the browser you're using. I found Edge to be the most reliable, or certainly the one that enables most of the functionality as easily as possible. So Tim, I've just done a quick play and I can get the lasso to work upstream of Muppet. If you want to go through detail of how to do that, we could maybe try that in a minute if anyone's got no one's got any other questions.
There's one from Ed around the natural capital mapping and sort of the how the figures are calculated, and in the way we've not done perhaps a full detailed natural capital assessment. It has been quite a high level one that goes into this assessment here. So we take indicative natural capital values for the multiple benefits for a set sort of scenario, or a land use change, or goes from a baseline to the scenario, and we have values for that from our natural capital team, and they're on a pound per hectare per year basis, and then we scale it to the size of that field. So that's how the natural capital sort of method works. If that answers your question.
It's in alignment with all the other EA natural capital assessments as well. And they're kind of based on BEST and NEVO and kind of other known tools. So the industry standard practice sort of approach used to the hydrology kind of rolled over to natural capital as well. Sarah's asked how we've kind of assessed the land use change option. So do you want to talk through how the infiltration options work?
Yeah, so let's go up to this map dashboard here. So you're right, we have the three scenarios for the infiltration part of NFM Studio. We've got the land use change, which I can understand is quite confusingly named, but essentially we're modelling a sort of stepwise, almost successional change in land use. So an arable would go to a pasture, and a pasture would go to a natural grassland, and a natural grassland would go to a woodland. So that's how we're sort of changing land use in that measure. In the woodland creation one, everything's going to woodland. And then in the soil recovery, we're modelling a reduction in bulk density to sort of model aeration practices that would then allow more volumetric reduction, water storage in the soil under that option. So I hope that answers that question.
And if you go, Sarah, if you go back to the slides, when we circulate the slides and have a look at the Daly Morgan Finney model, those kind of approaches have been used in that input-output modelling approach. So you can see the sort of the way that what Emily's just described, the statistics have been put into each catchment, each plot within that modelling approach, and that's how we've applied it essentially.
That's great, thank you. Thanks both.
Yog's asked the question that really annoys me every time this one comes up. Not anything to do with Yog or the question itself, but it bugs me that we've not been able to do it. Unfortunately, we've come up against several limitations of ArcGIS Online with this as to how we had to present it, or how things interacted, or the fact that we couldn't get the opportunity map to talk to the natural capital map. So if you made a change in one, it wouldn't update the other. And some of those things weren't possible. And the sort of more fundamental one that irked me a little bit was we can't just have a create PDF button or something like that to create an export from the online dashboard. So you can do things like send it to a PDF printer within the browser that you're using, or you can take a screenshot. But unfortunately, there's no kind of formalized create me a thing from this what I've got on the screen at the moment type functionality. Did anyone have anything they wanted us to go through more specifically in any more detail? I think I meant in the questions it came up about other inputs to the hydrology spreadsheet, and it actually so it'd be good to do a little bit about the FEH tab and the hydrograph analysis tab, if that's okay.
Yeah. Yeah, I did very rush over these other two tabs. So this baseline flow data tab is where we store the our baseline hydrographs that have been outputted from REFH using Flood Modeler. So that's there. And the hydrograph analysis tab does allow you to enter a different hydrograph that you might have for the catchment or subcatchment, and then enter either selected or all NFM intervention volumes in these green boxes, and it will again show an updated hydrograph. It does have the base flow and land runoff sort of superficial part of the hydrograph separated, and this is due to how we apply some of the assumptions and how we apply those volumes from the from NFM Studio into the hydrograph. So when we look at the outputs from the land use change or infiltration measures, we assume reductions in superficial runoff get taken off the sort of superficial part of the hydrograph, but any modeled infiltration to deeper parts of the soil gets added back in to the base flow, so we're not necessarily losing water from the model. So that's why we've got it separated out, those two parts of the hydrograph. And yeah, it's a useful thing to have there if you want to interrogate a different hydrograph. And then there's also this macro here, this extract hydrograph flow, and also on this tab here, extract hydrograph flow. So if you were to click that, it simply turns these graphical hydrographs into show you lots of numbers, and so allows you to sort of look at sort of peaks and things like that, which is useful to have. And again, it's split out. Purple is the baseline, orange is the all NFM catchment wide, no constraints option, and the selected in green is the ones that you would have inputted into those green boxes.
I think one thing to mention, that the baseline flow data tab is the outputs of the flood estimation handbook process for the different return periods. So eagle-eyed of you will have noticed in the beer polygon, the polygon is bigger than sort of one watercourse. There's a couple of watercourses in there. So if you needed to discretely analyze one watercourse, again, another limitation of the project and the process was amount of catchments we could subdivide the area by. You know, we could have gone to 500 or 1,000, but we'd have had so many different data sets that managing the data would be quite problematic. That's an issue as it stands. But there are other tools that allow you to derive this data specifically for one watercourse within the polygon. Then you can still use the lasso tool and everything around the area that you're interested in. But if you wanted a more bespoke hydrology for one tributary, you could get that and put that in here as an alternative hydrological baseline. Matt asked in the questions about how we would apply this to a specific catchment. So that's quite a big question, but I mean, it depends on the area of expertise you have. So the goal with the tool is to make it useful for people in the agency that are going to run flood risk projects or environmental projects, catchment partnership members that might want to do the same thing with different pots of funding, or an advisor to a landowner or a land manager to have a look at something discretely at the plot scale. So yeah, in East Devon, you can use the overview tab or the view we're in at the moment to compare catchment with catchment and see where you may derive more impact from working. When you get into the plot scale, I think the greatest functionality is the lasso tool, looking at it at the farm scale, being able to zoom into the areas that you're interested in. Once you know which catchment to look at, to be able to say, well, what can I achieve on this farm? Where are the priority fields? This doesn't do anything around impact to property specifically. It will give you, that's something we ought to point out in a second, and if you can make a mental note of where the property counts are. This is purely about the ability to change natural processes and derive positive or negative outcomes from that. So it's very much a tool that is there to use with local knowledge. It can help you work out which bits of the catchment to go and have a look at in more detail. So the sliders or the lasso tool and finding, field-specific information would then enable you to go and say, well, actually, in this instance, we think we could do a bit more because the theory, the logic that's been applied in the tool is not quite right with the topography in this location, or we think actually there's a bit less because there's this issue on the farm, or the farmer doesn't want to do X, Y, and Z in these fields. So this is all theory. It needs to be applied with some sort of semblance of knowledge of the location, whether that's high-level assessments or whether that's detailed farm visits. It can still do both of those things, but I would always encourage using it with a visit to the site. It's just kind of a good practice to do that. So you can go in, you can analyze the fields, you can analyze with the lasso tool, you can analyze with the slider. It depends entirely on how you want to see the information, and it depends on the outputs you would find useful. If having those kind of summary statistics on the right-hand side to say, well, on this farm, we can generate X much increase in infiltration, or we can increase the natural capital value by doing this by this much, you can get those sorts of pieces of information from the slider. From the lasso tool. If you're looking more high level to start with, I'd say probably the slider is more useful. You can use that to determine where to go and look. You can say, well, if I increase this halfway up the slider, that's sort of the top 50% of the benefit potentially. That's something we need to explain a bit in a second as well, actually, why they're slightly different from one another. So that would help you determine where to go and look. And then the lasso tool, applying that farm scale knowledge. Emily and Dave mentioned the opportunity scoring being on a scale of 0 to 1 as our scoring regime that we've applied. If you look at the infiltration sliders, the second and third one, you'll see they're from 0 to 84 and 0 to 133. Those are just the sort of ranges of figures in those fields for this management catchment. So if you end up using this tool across different management catchments, you might find that spread of fields is the extremities is different. The numbers at either end are different. 0 won't be, but the upper one will be. And the point at which land parcels start to disappear between either end of the slider might also be different as well. So East Devon might be particularly sensitive to the bottom end of the slider, for example, whereas North Devon might be on the right-hand side, depending on the distribution of plots on that scale. So they are subtly different from one another. The opportunity score and the volume, equally from catchment to catchment, they're geographically distinct.
Can I just add something, Tom, actually, into how you use the data, actually? I think one of the particular uses that we can see and why the information is provided in GIS format as well is for this type of data to be embedded in the design of anything that you do. So for the catchment of beer, I mean, I'm not sure what the detail is of what everybody's thinking is, what the problems are. There will be some maps of information and so on that explain that already, or things that people are doing. And it's just that making sure that this information is available to you to overlay alongside those other bits of information. So there is a sort of design intention here as well. It might be something that we can pick up on later, Tom, isn't it?
Yeah, definitely. I mean, I think it's once people are used to using it, the ability to zoom right into the farm scale and almost play with it at the kitchen table with the farmer to see what could be done is there. Again, it's sort of proportionate, and it's as simple as we've been able to make it with the tools available to us. But if you just wanted to plan an initial walkover for a catchment, it can help you with the opportunity score, so you can see where it could be easier to do NFM. You can use the volumetric data to say, well, where's the greatest impact? And in that sort of little matrix that Dave shared, you'd be able to see where are the highest impact, highest benefit places that are also easy in the easier sort of half of the spectrum to deliver on the opportunity score. Go and look at those locations, obviously try and find bigger plots, try and find areas where there's more conjoined features. So you can use it to sort of do that kind of analysis of where to look at first. So I'd say, going back to this kind of hypothetical way to use it, that would be my approach. And then I would look in at the field scale in more detail about, well, what could you do? Which bit of that kind of conjoined cluster is more useful, more impactful?
You also wanted Tom to talk through about the properties at risk. That's in the OM4 information, isn't it? So that's in the catchments overview tab. The initial screening, is it? And then when that loads, turn the hydrometric off. And similar to other data sets, you can sort of click on that field and it gives you that information that's part of that data set. And then there's also the further assessment that you can also view and click on. It gives you that information there as well.
Yes, I mentioned this in the chat. OM4, we have 4 kind of key outcome measures related to flood risk funding. You know, for me, that's the driver for this, and for some of you that want to access that, it's worth being aware of. It's an entirely separate conversation about economics, but outcome measure 1 is kind of the overall benefit to society. And it also includes things like commercial property damages, reduction in incident response costs, all sorts of things like that. Outcome measure 2 is the primary one. It's about the number of properties protected. So Tim, going back to your question about, well, what's the sort of benchmark that we're trying to get to? If it's to reduce risk to a community, the number of outcome measure 2 properties that will move from one band of flooding to a lower band of flooding, you know, the return periods that we're talking about in the tool, that's where outcome measure 2 comes from. That's how we generate the cash, is to demonstrate that reduction in risk. I don't want to go too much into that because the rules around how that applies to an NFM scheme are being simplified in the background, but they're not there yet and they're not shareable yet. So if anyone's got any specific questions on that, do come to me and I'm more than happy to help you. It's probably a little bit of a weird situation where the rules are changing, but they haven't changed yet, but we might be able to use the new system. So that's kind of a bit of an awkward one at the moment. Outcome measure 3, not relevant for this at the moment. Coastal erosion, number of properties that are likely to fall into the sea over certain periods of time. And outcome measure 4, as we said, is sort of the habitat that could be created. So the reason NFM is interesting locally is because traditionally our schemes have struggled to justify large engineering solutions, other than a handful of locations across the programme. The funding metric that we have has been given to us by DEFRA, by Treasury, and that's sort of Treasury Green Book compliant, but it works across the whole country to distribute flood risk funding. So BEER could compete with a refresh of the Thames barrier, and they'd be competing on equal ground based on the number of properties that they can move to a lower band of risk, the amount of habitat they could create, and that overall societal benefit figure. Because they'd be competing, they wouldn't be eligible for anywhere near the same amount of money. You know, the Thames barrier protects hundreds of thousands of properties and BEER might have a handful. So to give BEER a meaningful reduction in risk, we have to look at what's achievable through NFM, because an engineered solution is likely to be maybe a bit tricky in terms of aesthetics, but also space and size and locating it in a steep, small catchment in a small community with tightly packed properties. So in quite a few instances in communities like BEER, ENGO advisors, Natural England advice, woodland officer, consenting processes, you know, those things may be the only way for us to reduce flood risk to that community. So I'm really keen to understand how we can embed this more in processes for those kind of funding applications, advisory roles, all that sort of stuff. Yeah, the funding side of things is one thing, but that won't work in a few locations, potentially quite a few locations. So what we need to do is explore how can we link those two streams up, the provision of advice and grants and our flood risk funding. And hopefully the tool will allow us to do that. But what I suspect will need to be done to understand that is more offline conversations at an organisational level about how we work, how the tool could support those activities, and how we can try and piece them together. And again, if anybody wants to do that, I'm more than happy to have a conversation offline. Matt's asked, can we put it in an app? So I've tried using it on the browser on my iPad, and the iPad doesn't have enough memory to run it. It's a bit long in the tooth as a device, so I think you'd need a fairly potent device to do it. That is something that we can have a look at for if and when an update happens, is to have a sort of lighter touch version. I should say, just quickly, and then I'll shut up and let someone else speak. There are no planned updates for it for the time being. It needs to go out there, be used, understand how it fits with those other organisations for a while, potentially a few years, and we'll see how it goes. If there is a need to do an update, I can explore that. But yeah, for now it's a case of use it, see how you get on, and I'll be collecting lots of feedback. Tim's just suggested something at the Catchment Partnership, looking at in more detail. You know, if you guys want that, more than happy to attend and help you go through that in the future if that's useful.
I had a question, if that's all right. It was just related, really, how's NFM Studio been shared with landowners, and if so, what's their response to this platform as a way of visualizing the potential benefits and opportunities?
It's a good question, Alex. So it's worth noting landowners weren't our kind of intended audience for it, more the advisors. It's not been around and in use on projects for long enough to know a sort of big pool of landowner feedback, but I have shown it to a couple, and they've kind of liked the transparency of it without necessarily sort of feeling dictated to about what could happen. I think the key thing is the message that goes with it is, this is not planned, this is not definitive, this is not telling you what will be done, this is just showing what could be possible. And the interactive nature of it was they quite liked it, being able to sort of sit and see what could be done, you know, what fields were eliminated at certain points on a slider, and how things stacked up against one another. So yeah, a small pool, but relatively positive feedback. But I think that message that goes with it is quite important.
And the fact that everything that's fed into the tool has been open source means that it is a public link, so anyone can go and explore it.
Yeah, I'm more interested in kind of different user groups, how people find using it. If you've not got much experience of looking at hydrology, or you've got loads, or you've got a landowner role, or you're in a community group, I'm quite interested in understanding the different user groups and what they feel they need out of it. It's our first stab at doing this. It's the first stab in the country at having something interactive like this. There are other tools that are a more static version elsewhere in the country. So there's going to be a little bit of a learning by doing process of having this sort of public link and making it readily available and open source. It's going to need reviewing over sort of its lifetime. Just in Matt's comment, building on what I was just saying about rolling out across the country. I don't think there are any national EA people on the call, so hopefully I'm not going to be speaking out of turn, but there's some work going on to understand what could be done like this nationally. Now, I don't think there's going to be a commission of a tool like this for everywhere. There are neighbours in our neighbouring EA area in Wessex who are working with Emily and Dave and the team to do more of this. So the whole of the southwest will be covered at some point in the not too distant future. 3 or 4 other agency areas around the country have asked me about it, but they're procuring it independently. Others have other suppliers. Arab have got something similar. JBA have done other things as well for Tim and others in other locations. So in terms of a national commission, I think it's more likely to be a set of principles about what the outcome should be, rather than a sort of dictatorial, here you go, here's a product. So if other areas want to use it, obviously there's elements of this that are transferable. The calculator, you could find your own local hydrology and plug stuff into it, but the team at Atkins can advise on how to do that. But yeah, it's not a national thing at the moment, and I don't think there's any aspiration to just copy and paste it nationally as it stands. There's interest, but I think unfortunately the horse has bolted, and areas have already started doing their own thing like this anyway.
Well, I don't think we have any further questions in the chat. I don't know if there's anyone else wants to speak out now. Any final questions at all?
I've got a couple of things on ongoing support just to share, if that's all right. I'm going to have to quickly dive back onto PowerPoint because I'll forget them otherwise, so bear with me. I think the key thing is the contract finishes at the end of this month. Now, that doesn't mean Atkins and I are going to disappear and leave you to your own devices. It just means I won't have a live contract with Atkins to be able to do it for free. So we have some sort of long-standing resources alongside this. There's the link to the tool that Dave's put in the chat. There's also some YouTube videos on the Atkins YouTube channel, which have been put into a little NFM Studio playlist. So each of those videos there give you an overview of what's the dashboard look like, how does it work, and then sort of incrementally more detailed versions of how we've gone through everything we've gone through today. So this recording will be sort of one resource. We have the report that goes with the tool, but each of these videos as well is quite a useful kind of refresher guide. You know, we don't have to do another one of these sessions for you. They're on YouTube as a standalone. You can go and visit those and use them as it suits you. Pause it, go along with them, and, you know, keep kind of dipping in and out of the video and following along with the tool as you go. As I said a few minutes back, I think this has got kind of a finite life of a few years. You know, I'm going to hopefully be using it for our flood risk program up to 2027. But the science of NFM is evolving very quickly, so I'm not going to promise, you know, when are we going to do an update or anything like that, because that's all a bit of crystal ball gazing, which I don't really want to get into at the moment. But to help us know what is and isn't working, there's a feedback tab on the tool, and the far right-hand tab. Do please use it, because it will come into Atkins and myself so that we know, you know, where you're finding it complicated, where you're finding it's not clear, or we could have done X, Y, and Z differently. Really keen to try and understand those things, because if we do plan an update, having that intelligence back from you all is obviously invaluable. I've mentioned the YouTube playlist. There is a technical report which I can provide if people want to see all the detail of how it's been done, that opportunity scoring that Dave kind of alluded to in his presentation. They do have all the GIS files on this hard drive. There's a lot. So if you want it, there's 250 gigabytes worth of data on here. So the actual transmission of that much information is probably going to be a little bit problematic, and maybe a bit more old school physical handing over of a copy, or coming into the office and copying it over and what have you. So unfortunately, just bear in mind, if you want it, it's not a lightning quick provision of the GIS files at the moment. I do have some funding allocated to do the model reruns. So where I was talking earlier about taking NFM Studio and the hydrological analysis you've seen, and then kind of plugging that into a flood risk model. We do have a rolling pot over a number of years for rerunning flood models where they exist. Obviously, we're going to try and prioritise that for the EA investment programme and for the Risk Management Authority investment programme where it's required. If others want to make use of that, we just have to have a conversation about what's the flood risk benefit and that kind of thing. So the opportunity may be there to help fund an update of a model rerun if you want to try and access funding subsequently. The team I work in is called Partnership and Strategic Overview. Never means anything to anyone in any of these sessions, but basically we're the team that kind of manage the strategic plans around flooding, the investment programme, run projects and so on. But we're also the custodian of all of the national flood maps and things like that. So because of that data role, there's 2 people being trained up in the Devon team and the Cornwall team, who will be kind of more detailed users of the tool alongside me. I'm not going anywhere. Atkins are still our contracted preferred consultancy supplier for a number of years, so the team will still be around. And yeah, as I said, just make sure you tell us if we know what you want and we know what you like and don't like, we can see how evolving the tool goes over the next few years. And if we do plan an update in, the feedback from you is really useful. Just a final plea, really. I'm working on a paper about nature-based solutions and how the agency delivers them locally. All aspects, not just data. Keen to get any feedback on that side of things from you all. What do you feel we should be doing about liabilities or funding access or anything really? John's just asked an interesting question in the chat. Do you envisage this potential to scope some of those multiple benefits, recreation, health, well-being, to draw in funding? Yes, yes, John. From a selfish point of view, the reason I put multiple benefits and natural capital into it was to identify a sort of beneficiary route. So if we implement a solution in a certain location and we know it does X hydrologically, we can then look at what else that achieves in terms of natural capital. So if we know there's an air quality benefit and there's a road nearby, it might be that there's some form of transport pollution reduction fund, or if there's a soil issue, we can look at all of the kind of supply chain back into agriculture. So yes, absolutely. I think it's just a sort of more of a train of thought you need to apply to that rather than something the tool discreetly does for you. But my aspiration always was, well, here's the flood stuff, understand how the flood behaves, what else is a benefit, and therefore of those benefits, who pays, who's the beneficiary, what funding streams exist, and so on. So yes, but not directly, I think is the answer to that.
Brilliant. Well, I don't see any further questions. I don't know if there's anything else, Tom or Dave or Emily, you wanted to cover at all in this session, but I think I speak on everyone, it's been extremely beneficial and very interesting. Certainly something we're going to use in the East Devon Catchment Partnership going forward, and I think there are others from other catchment partnerships on this call as well. And I think everyone's found it a very beneficial session. So thank you very much for your time. It's been a brilliant morning. And yeah, unless there is any further comments or questions, I think we can draw it to a close there. And I will obviously circulate the recording. I do wonder, is it worth putting this recording on the YouTube, or perhaps I could just send it around to the catchment partnerships individually? We can talk about that outside of this meeting. But,
brilliant. Yeah. Thank you, Alex. Thanks everybody for having us. Like I said, we're not disappearing. So if you've got any questions after this, at the very least, Alex has got my email address. If you can't find it from the invite, just shout. Happy to help. And yeah, thanks again for allowing us the sort of final session before the contract winds up to share it with you.
Thanks all. Have a lovely afternoon, everyone. Cheerio.
Cheers. Thank you all.
Thanks, everyone. Bye.
Thanks, everyone.